Hello children, I am Sonali Kelkar from City International School and today we are going to do a very important topic, that is sign convention for the spherical mirror, right? This is from the chapter first, light reflection and refraction, right? So let's do the sign convention first in case of concave mirror, okay? So before we go with the sign convention, I want to remind you about the graph. Okay, now according to the graph, as you all know, okay, this is the x-axis, this is y-axis, this is y dash, x dash, right? So anything which falls over here, they are positive. Over on the x-axis, all positive. Right hand side, and this is left hand side, right? Right hand side are positive numbers, right hand side of origin and left hand side of the origin are negative numbers, right? On the top, if you go on the top of this, vertically, if you go vertically up, the numbers are positive, and if you go vertically down, the numbers are negative, right? So this is what you have to remember. Fine. Here also we are going to place a mirror. Just place the pole of the mirror on the top of the origin O. So this is what is my pole. Fine. Now if I place a mirror over here, then whatever quantities which will fall on the right hand side will be positive. So right hand side will be positive and left hand side will be negative. Right hand side of my mirror and left hand side of my mirror. Left hand side negative and right hand side all will be positive quantities, right? Fine. So there are 5 points which you have to remember. There are 5 things which you have to remember when we are doing the sign convention, right? The first one is U. What is U? This is a object distance, that is the distance of the object from the mirror. So in a short form, object distance. Clear? Then V. V is image distance, right? It is a distance of an image from the mirror. So in a very short form, image distance. Clear? U object distance, V image distance, right? So when we read A, B, C, D, F, G, U, V, X, Y, Z, so U come first. So object, obviously the object has to be the first one, then only the image is formed, right? So U object and V for image, okay? Then comes F. F is a focal length. Now what is focal length? It is a distance between the pole and the focus. It is known as focal length, right? Now H stands for height. H stands for height. So height of an image or height of an object, right? So H stands for height of an object and H dash stands for height of an image, right? So I'll write that height here. Object. This is height of an object, right? And this is height of an image. Object. Right? Height of an object, H, and height H dash is height of an image. Now, if these terms are clear, we shall go ahead. Now, regarding the convention, what I told you, whichever things falls on the left hand side, negative, right hand side, positive. See, you always get right positive numbers for right answers, right? So right is positive, left is negative. Fine. Okay. Now the top of, if you are going above the principal axis, okay, regarding the height, above the principal axis it is positive, below the principal axis it is negative. You can see here in the graph, when you go vertically up positive and vertically down negative y, right? Vertically up positive y and vertically down negative y. So this is what we have to do here. Now as we know that, let's start with the U. Okay, U is object distance. We know that in case of concave mirror, okay, let's see the concave mirror first. We have done the concave mirror, right? Okay, now in case of concave mirror, object is always placed on the left hand side of the mirror, on the front of the mirror. Okay, in case of concave mirror. Now, what about in case of convex mirror? Even in case of convex mirror, we place object in front of the mirror. So, we can say that the u, that is the object distance, will always be a negative. If I tell you the object is placed 20 centimeter, that means when you are substituting the value of u in the formula, you have to write as minus 20. Clear? Here you cannot write plus 20 because we know that object is placed on the left hand side of the mirror, in front of the mirror. So the object distance, if I give you 20 centimeter, then you have to take minus 20, right? The value should be minus 20. Now coming to the second is image distance, right? So let's revise all the ray diagrams of concave mirror. So in case of concave mirror, we did 6 ray diagrams, right? There were 6 ray diagrams. In that 6 ray diagram, 5 ray diagram, the first 5 ray diagrams, okay, the images were formed on left hand side. They were real, they were inverted, they were real and they were inverted. So images were on the left hand side. So that in that case, you have to consider V object, image distance should be negative, right? Negative. Okay. 5 ray diagrams. In 5 ray diagrams, right? In 5 ray diagrams, we have to consider that the image distance was negative. Except the last one where the image was formed on the right hand side of the mirror, right? An image was vertical. Okay, so vertical image is always positive, right? Vertically and erect, they are positive, right? Except the first one, the sixth one, fine. So here you have to remember this point, okay? The sixth ray diagram, okay? Fine, the sixth ray diagram. Now in case of focal length is always, we have considered between P and F, this was a focal length. The focal length is always negative. Focal length is always negative in case of concave mirror because the object was placed here. Okay, because the object was placed over here. The focal length in case of concave mirror is always negative. We are considering this as a focal length. But in case of convex mirror, the image was formed here at focus or between focus and pole. So in case of convex mirror, the focal length will be considered as positive, right? So this is a very, very, very important point. If I tell that the distance between the pole and the curvature is 30 centimeter, okay, and the mirror is concave. So in this case, how we are going to find out the focal length? We know that focal length is half of the distance between center of curvature and pole, what do we call that distance as radius, right? Radius. So focal length is half of the radius. Okay, so if radius is 30 given, then you have to do the half of it. That is 15 centimeter, right? 15 centimeter. And then in the question it is given concave mirror. So you know that concave mirror focal length is always on the left hand side. So that is always negative. So you are going to take focal length as minus 15. Clear? Fine. So fine. Now what about the height? Right? In case of a height, the height we have placed object always on the top of principal axis. So height is always positive whether it is a case of concave mirror or convex mirror. Clear? Right? And what about the height of the image? Right? So in case of concave mirror, it is very simple. In case of concave mirror, first 5 diagrams, okay, where the image is formed, image was real and inverted. inverted mirror was below the principal axis, right? So in that case, height you will consider as negative. Clear? So height that is below the principal axis, negative, and if it is above the principal axis, it is positive. So height of an object is always positive, and height of an image in case of the first 5 diagrams, ray diagrams of concave mirror, the height is negative. Okay, height of an image is negative. Whereas in the last diagram of concave mirror, okay, we got a virtual and erect image at the left hand side. So height will be considered as positive, right? And in case of both the convex mirror, height are positive. So it is very simple to understand. Now let's consider the case of convex mirror. Okay, in case of convex mirror, let me draw a convex mirror here. Okay children, now let's do the sign convention in case of convex mirror, right? Let's do the first one, that is the U, which is nothing but the distance between the object and the mirror. As I told you, U is always negative. We always placed object in front of the mirror. Object is always placed in front of the mirror, so U is always considered as negative. Now coming to the image, right? The image in case of convex mirror, we have only 2 ray diagrams of convex mirror, right? And in both the 2 ray diagram, first the image was formed at F, which was highly diminished and vertical and erect, right? So in that case, the image is at F, that is on the RHS, the right hand side, right? So that will be considered as positive. So in case of image in convex, images are always positive, always positive. Always positive.
तो फ्लशचा आवाज आला तुला कळत नाही.
So in case of in case of convex mirror, image formed is always positive because it is formed on the right hand side of the mirror. So convex mirror are very easy to learn, very easy to learn. U always negative, concave, convex. V, image is always formed erect, virtual, right, and on the right hand side, so they are always positive. Then F, here there is a little change. Focal length in case of convex mirror is positive. So everything is positive in case of convex mirror. Okay. In case of convex mirror, everything is positive. This except U. Fine. Let's see. Focal length is positive. Height always positive in case of convex and concave mirror. In both the case, height, that is the object, is placed, okay, on the top of the principal axis, always positive, right? And then height of the image was always erect and virtual in case of convex mirror. So height of the image is always positive. Always positive. So to remember all this point in case of convex mirror is very easy. Now children, let's do the formula, mirror formula. Okay, and we will do a numerical based on the mirror formula. So children, let's do the mirror formula. It's very simple. Mirror formula is 1 upon V plus 1 upon U is equals to 1 upon F, right? And let's do one problem based on this formula, right? So the problem is if an object is placed 10 centimeter from a convex mirror of radius of the curvature 60 centimeter, right? Then find the position of an image. Here, whatever they have given, what are the important points that you have to understand, that if an object is placed, that means the object distance, that is U is given, right? That is 10 centimeter. So as I already told you before, that U will be considered as negative in concave and convex mirror. The object is always placed on the left hand side. So that is why I have taken minus 10 centimeter. So U is object distance 10 centimeter, right? And the mirror of radius of curvature, so R, capital R, radius of curvature is 60 centimeter, right? And what about the focal length then? Focal length is half of the radius of curvature. So 60 divided by 2, that is 30 centimeter. And what about the focal length in convex mirror? Remember, the focal length in case of convex mirror, it is on the right hand side. So that will be positive 30 centimeter, right? Now, what we have to find out? We have to find out the position of an image. That means we have to find out V, right? So let's find out V. So see children, whenever you do these type of numericals, mirror formula, first you write down given and then you draw a rough diagram of this convex mirror or concave mirror, whatever is given according to the numerical, and then go ahead with the solution of the numerical. Because we have already done the ray diagram so many times, so I am not drawing a diagram here. In the exam, please do draw the diagram. So it will be extra, you will get extra marks for that. Okay, so let's do the numerical. So let's substitute the value 1 upon, what you have to find out? You have to find out 1 upon V. So I'll take 1 upon U over this side, right? So it will be 1 upon V is equals to 1 upon F. When I bring 1 upon U on the other side, what will happen? The sign get changed. So it will be minus 1 upon U. So this is what is your formula now, and you have to substitute the value. 1 upon V is equals to what is F? F is 30 centimeters, so 1 upon 30, right? And U is minus 10. So this minus, you have to put this minus. It is there, right? And when you are substituting the value of U, at that time, what you have to do? Put a bracket, right? 1 upon, okay, minus 1 upon 10. Clear? We never put negative sign in the denominator. Fine. So you have to bring it at the top. Minus 1 upon 10. Okay. So write it in the middle or the top. Okay. So now what will happen? Find out the LCM. 30. Now this sign, there is a negative sign inside and outside. So it will become positive, right? So I'll just cut it and make it positive. Clear? So it will be 1 upon 30 and 1 upon 10. So what is the LCM of 30 and 10? 300. This will be 30 plus 10, 40, right? Cut it. 2 2s are 2 5s are, right? So you are getting 2 upon 15. So when you solve 2 upon 15, it will be 2 ones are 2 and 7.5, isn't it? Divide 15 by 2, it will be 7.5. This is 1 upon V, right? And what we have to find out? We have to find out V, the position of image. So V will be reciprocate. You will be getting 7.5 centimeter. Practice the problem based on the formula, mirror formula. More you practice, more your concept will get clear, right? I've just taken one example over here. So students, now let's do magnification of spherical mirror. What do you understand the magnification of spherical mirror? It is a relative extent to which the image of an object is magnified with respect to the image of an object is magnified with respect to the object size, right? How much the image has magnified with respect to the object size in a very simple term. And the definition for this is, it is written in the formula, magnification is equals to h dash upon h, where h dash is height of an image. It is height of image divided by height of an object, right? Height of an image divided by height of an object. So h dash upon h. There is one more formula, which is magnification is equals to minus v upon u. Minus v upon u. Minus v is distance of an image from a mirror upon distance of an object from a mirror. This is a negative quantity. Now you can write down the definition, that is, the magnification of a spherical image is the ratio of the height of an image to the ratio of height of an object, right? So let's now understand what about the magnification, right? Now if I am talking about magnification, that is when m is equals to when m is equals to 1, that means the height of an image is equals to the height of an object. Clear? When m greater than 1, that means height of an image is more than the height of an object. And when magnification is less than 1, it means the height of an image is less than the height of an object. Clear, students? Now let's prove it. How did we get that when magnification is 1, that means how can the height of an image is equals to the height of an object? Okay, so hi divided ho. Yeah, if I bring hi here, ho here, what will I get? Ho is equals to hi. That means height of an image is equals to the height of an object. Okay, now let's prove the second one, which shows that, okay, magnification of if magnification is more than 1, that means the height of an image is greater than the height of an object. So let's prove that. Okay, hi upon ho. Okay. Right? So multiply HO with 1. HI is greater than HO. Magnification of image is more than magnification of object. Right? Now let's prove the third one. When magnification is less than 1, that means the height of a image is less than the height of an object. Clear? How? Let's see. Height of an image, height of an object less than 1. Clear? Multiply this with this, what you will get? Height of an image less than height of an object. So this is how we have proved. Okay, this is just to have an extra knowledge. Otherwise, it's enough if you learn this much. Magnification, when it is 1, that means the image height and the object height is same. When the magnification is more than 1, that means the height of an image is the height of an image is more than the height of an object, and when the magnification is less than 1, that means the height of an image is less than the height of an object. Okay, and we have proved. So student, regarding the magnification of spherical image, we have two formulas. One is m is equals to minus v upon u, and the other one is m is equals to h dash upon h, where h dash is height of an image upon height of an object, right? So we have proved this, that how height of an image is height of an is equals to the height of an object when m is equals to 1, and when m is equals to greater than 1, how height of an image is more than the height of an object when m is equals to less than 1, then height of an image is less than the height of an object. When m is equals to greater than 1, then height of an image is greater than the height of an object. So we have proved this, right? So coming to the other part, that is when we see that magnification is negative. Okay, when we see that magnification is negative, so what does that negative sign means? Negative sign means that the image is real and inverted. Okay, when we say that magnification is positive, okay, when we say that magnification is +3, right, in that case plus, okay, the positive sign shows that the image is virtual and erect. Clear? 3, because it is more than 1, it means the size of the image is greater than the size of an object. Okay, so here if the real image is negative, then why it is negative? Let us prove that. So let's take a case where the image is formed in front of an object. So this is the case of a concave mirror, right? The image is formed in front of an object. Okay, so in that case, how should be the image? Because it is formed in front of an object, so it should be negative, because LHS, right? Negative. And now this is what should be the image distance? This is minus v, right? Image distance. What is the object? Object distance is always negative. Object distance is always negative. Object is always placed in front of a mirror, so that will be always negative. So minus u. Clear? This minus and this minus will cut off. This minus and this minus will go off. So ultimately what we are getting? We are getting an image which is negative. Okay. So what type of image we get in concave mirror, except the last one? All the images were real and inverted. So real or inverted mirror are always negative. We consider the example of concave mirror, right? Now let's do why it is positive and how it is positive. Now let's consider the example of a convex mirror, right? Convex mirror. Okay, now the image formed was behind the mirror, so that is positive, right? Now write the formula, minus v upon u is always negative. U is always negative, right? So in this case, this minus will go off. And what kind of image are we getting? We are getting images positive, right? So in case of virtual images, they are positive and erect, right? And this is a case of convex mirror. Okay, student? So children, here we have two magnification by spherical mirror, two formulas of magnification by spherical mirror, right? This one is image distance upon object distance. So this is a ratio of image distance and object distance, but negative, right? And the other formula H is H dash upon H, where H dash is height of an image, height of an image divided by height of an object. Clear? Now, the other thing with this formula, we came to know that the real images are always negative and the virtual images are always positive. Clear? Now, let's do one. Let's do one numerical. Very simple numerical. If I write minus 2. What do you mean by this? If the magnification is minus 2, what did you understand by this? The negative sign stands for real image. That means the image is image. What is the nature of the image? Image is real, and because it is real, it has to be inverted. The image is real and inverted. But what about 2? If the magnification is, okay, so magnification, if I tell magnification 2, that means magnification is greater than 1. It means the height of the image is more than the height of an object, right? Here, height of image is right, hi, height of image is more than height of an object. Clear? So, please don't consider minus 2 as a single unit. Okay, don't consider that it is a minus 2, so it is less than 1. So, the image should be, the height of the image should be less than the height of an object. No, it is not like that. The negative sign, okay, from the negative sign, you come across the nature of an image, and from the number, from the numerical, you will come across that whether the height of an object is same, or it is more, height of an image is more than height of an object, or it is less than the height of an object. So let's do one more numerical based on this. So the next one, if I write plus 0.5. Now what did you understand by this? The plus sign, we need to break this into two parts. The plus sign stands for nature of an image. Okay, that means plus means it is virtual. The image is virtual image. Virtual hai, if it is virtual, that means it has to be erect. Clear? 0.5. Now what about 0.5? See the magnification. If the magnification is less than 1, 0.5 is less than 1. If the magnification is less than 1, in that case, the height of the image is less than the height of an object. So 0.5 shows that height of an image, hi, okay, is less than the height of an object. Clear, students? So this is all about magnification by spherical image. Now, can you able to identify the image if I tell you the magnification? Okay, let's do this. If I tell you that the height of an object, okay, the height of an object is same as that height of an image. That means it should be 1, right? And the image is always virtual. Can you identify this mirror? Yes, it is plane mirror. In the plane mirror, the height of an object and image is always same, and it is always erect and virtual. So we can say that it is a plane mirror. Right? So what about when the height of an object is when the height of an object is enlarged, height is more. Okay, let's take height of an image is more. It is enlarged, right? than the height of an object, and the image is virtual, and the image is virtual. If it is virtual, it has to be erect. In this case, what should be the mirror? In this case, the mirror has to be concave mirror. See the last ray diagram where you keep the object between focal length and pole, and between the focus and pole, and the image you got is, it was enlarged and it was erect, right? So virtual and erect, and image is more than the height of the image is more than the height of an object. And what happened? So this is what is our concave mirror. And what happened when the image is virtual? Image is virtual, that is, image is positive, but the height is always small. Height of an image is always small than the height of an object. Here the image is virtual. Here also image is virtual, that is positive I have put, and height of the image is always small than the height of an object. So in this case, what should be the mirror? So mirror is convex mirror. Okay children, so this is all about the magnification of spherical mirror, and we did the formula of mirror. So please practice numerical based on the magnification and the formula of mirror, and this is all about today's session. Thank you so much.